stars as our own galactic neighborhood. But because the clusters are old, any massive bright stars they once had have long since burned out. The globular cluster sky would be crowded, but its glow would remain subtle.
If we were on a planet around a star in a globular cluster, we would see thousands of stars, but the average illumination at night would be comparable to the illumination you'd experience in a room with some candles lit up.
Orbiting out in the halo, globular clusters are to the galaxy something like moons are to a planet. Globular clusters on the outskirts of other galaxies show that this is something many galaxies have in common. Now, our route through space takes us far outside our own galaxy. 60 million light-years away, to a massive elliptical galaxy called M87 that looks something like a globular cluster itself. Most of the fuzzy dots in this photo from the Hubble Space Telescope are globular clusters orbiting M87. The giant galaxy has 15,000 of them. But M87 represents the upper end of the clustering phenomenon. It sits at the core of a cluster, not of stars, but of galaxies, where our starship now travels to witness the violence of giant star systems colliding at speeds of 1,000,000 miles an hour. All it takes is a few quick looks at star clusters to see how obvious gravity's effect is in holding stars together.
Gravity is like the sculptor of the universe. It influences large regions around it. So it can cause galaxies to cluster together just like stars cluster together, but on a much, much bigger scale, on scales of millions of light years. That's fantastic.
It's a process that begins right in our own astronomical backyard, where our spaceship prepares to fly outside the galaxy.
The Milky Way is a largish but relatively typical spiral galaxy, and we're located in a small galaxy group, which is a very typical kind of environment for material to be located in the universe. Only about 5% of galaxies are located in rich clusters, but more than half of them are located in small groups of galaxies.
Our galaxy's home cluster is called the local group. A trip across 3 million light-years takes us past its two big members, the Milky Way and M31, the Andromeda Galaxy. The Triangulum Galaxy is the next largest, and a few dozen dwarf galaxies circulate among them.
The galaxies within an individual cluster tend to gradually merge with time. So in the next 4, 5, 6 billion years, our Milky Way galaxy is going to merge with the Andromeda Galaxy.
Right now, if we view the whole universe from Earth orbit, our view screen looks like this. Our own galaxy's plane dominates, stretching across the center. But when we merge with Andromeda, the sky will look vastly changed.
And a very spectacular event, it's likely to result in an elliptical galaxy, which looks very, very different than either of the two component spirals.
Andromeda will fly by several times, as it and the Milky Way do a gravitational dance. The merger will destroy their elegant disk shapes. In the end, they'll settle into a giant rounded blob, the typical form of elliptical galaxies across the universe. The local group is tiny compared to the big galaxy clusters across the universe. The nearest big cluster is the next stop on our voyage.
Our local group is about 60 million light-years away from a much bigger cluster, the Virgo cluster of galaxies, consisting of thousands of galaxies, not just a few dozen. And our local group in the Virgo cluster and a bunch of other clusters are part of an even bigger structure called the local supercluster.